Hey everyone, ready for an awesome deep dive? We've got a fascinating article from scitechdaily.com called Inside NASA's High-Tech World, How Supercomputing is Unlocking the Universe.
Sounds pretty cool.
Oh, it is. Published just last week on November 24th, 2024, this article is going to give us some incredible insights into how NASA is using supercomputers.
Definitely.
We're going to be talking about everything from designing spacecraft to unraveling those mysteries of deep space. It's mind-blowing stuff, so get ready to have your mind blown as we take a deep dive into the world of NASA supercomputing. Okay, so first things first.
Yeah.
What exactly are supercomputers, and why is NASA so obsessed with them?
You can kind of think of a supercomputer like a massive team of brilliant minds all working together on one single problem.
Oh,
They can crunch numbers at just crazy speeds, way faster than your typical computer.
Wow.
And that lets scientists tackle these incredibly complex challenges.
So it's not just about having a fast computer then.
Yeah.
It's about having a whole army of processors all working together. Yeah, precisely. And that power is essential for things like simulating rock relaunches, modeling the climate, or even looking at the hearts of distant galaxies.
So cool. And speaking of rocket launches, this article talks about how NASA used supercomputing to redesign the launch pad for the Artemis mission.
Oh, yeah.
Which is super exciting, by the way, because it's the first crewed mission to the moon since Apollo.
Yeah, for sure.
But why did they have to redesign the launch pad in the first place?
Well, during the Artemis launch, the force from the rocket's exhaust was so powerful, it actually caused damage to the mobile launcher platform.
What? Really?
Yeah. Remember, we're talking about a crazy amount of energy released super fast.
Okay, yeah, that makes sense. So they had to figure out how to stop that from happening again, especially with astronauts on board this time for Artemis II.
Right.
But instead of building all those physical models and testing them out, they used supercomputers.
Exactly.
Whoa.
They used software. It was called Launch Ascent and Vehicle Aerodynamics on the Aitken supercomputer.
Oh.
And this let them basically create a virtual model of the launch pad and the rocket.
Wow.
And that let them simulate the entire launch process.
So.
And then they studied how the exhaust plumes and the water suppression system interacted. Really complex stuff.
It's like a video game, but with real-world consequences?
Uh-huh. Kind of, yeah.
Did the simulations show what caused the damage?
We did, yeah.
What was it?
So the simulations actually created hundreds of terabytes of data.
Wow.
And it turns out that while the water suppression system was doing a good job of reducing pressure waves, it was also redirecting those exhaust gases in a way that caused these significant pressure increases in certain areas. And that's what caused the damage to the launch pad.
Oh, so they basically recreated the problem virtually to find the issue and come up with a solution.
Exactly.
That's amazing.
Yeah.
What did they change on the launch pad based on what the simulation told them?
Well, they redesigned the flame deflector.
Okay.
And they actually made changes to the mobile launcher itself, all to better handle the forces from these massive launches.
Wow. That's a powerful testament to what supercomputing can do. Like, you can test these designs in a virtual world before actually spending all that time and money on physical changes.
Exactly.
That's so smart. It's like they're predicting the future of a rocket launch and then making adjustments to make sure everything goes perfectly.
Yeah.
Speaking of making things perfect, though, the article also talks about how NASA is using supercomputers to design more fuel-efficient airplanes.
Yeah. Right?
I mean, we all want cheaper and more environmentally friendly flights, right?
Definitely.
So how does supercomputing help with that?
It's all about reducing drag.
Drag.
Yeah, the air resistance that planes have to fight against while they're flying.
Okay, yeah.
By using supercomputers, researchers can basically run hundreds of simulations, testing all these different wing shapes and fuselage designs, all those features you see on a plane, to see how each one affects drag.
So it's like a virtual wind tunnel.
Yeah, exactly.
Where they can try out tons of variations without having to build anything physical.
Right.
So cool. What kind of results have they seen?
Well, they've found that they can reduce drag on existing commercial aircraft designs by as much as 4%.
4%? That doesn't sound like a lot.
Well, it might not sound like much, but when you think about how many flights there are every single day, that 4% reduction adds up to millions of gallons of fuel saved every year.
Wow.
It could significantly reduce the aviation industry's impact on the environment.
That's amazing. Plus, less drag probably means quieter planes and maybe even faster travel times, right?
Yeah, exactly.
Okay, so we've gone from preventing disasters on the launch pad to making airplanes better for the environment.
That's true.
What else is NASA using supercomputers for? Because I know this article hints at some really cool stuff.
Well, let's talk about neutron stars.
Neutron stars. What are those again? Aren't they like the dead cores of stars that have collapsed in on themselves?
Yeah, they're some of the most extreme objects in the universe.
I know, they're incredibly dense.
Right, imagine a star with more mass than the sun, all squeezed into a space the size of a city.
Okay, yeah, that's dense. But what do neutron stars have to do with supercomputers?
Well, NASA scientists are using supercomputers to create really detailed simulations of neutron stars.
Oh, wow.
They're trying to figure out the physics of these crazy environments, how they form, how they behave, what secrets they might hold about, the fundamental nature of matter.
So they're building virtual neutron stars to figure out how they work.
Basically. They want to understand things like what neutron star matter is made of, how strong their magnetic fields are, and what causes those intense bursts of radiation they give off.
Wow, it sounds like trying to solve a puzzle with like a trillion pieces.
Great, it's a challenge, that's for sure.
How do they even begin to simulate something as complex as a neutron star?
It involves a lot of data from telescopes like the Fermi Gamma Ray Space Telescope and the NICER Observatory.
Okay.
And then they combine that data with really sophisticated algorithms and computational models.
So it's not just about having raw processing power. It's also about using the right tools to understand that data and make sense of these crazy objects.
You got it.
So cool. What kind of tools are we talking about?
Well, they're even using AI now, like deep neural networks, to analyze those tiny fluctuations in light coming from these objects.
Oh, wow.
Which can tell them things like the strength of their magnetic fields and the stuff that those ultra-dense cores are made of.
It's like having a super-powered detective working on the case of the mysterious neutron star.
Haha, yeah.
Okay, so from recreating rocket launches to figuring out the secrets of dead stars, it's pretty clear that supercomputers are helping NASA push the boundaries of what's possible in space exploration.
Oh yeah, absolutely.
But they're not stopping there, are they?
Nope. They're also using supercomputers to study the sun.
Okay, now that's something we can all appreciate, right? The sun can be pretty intense sometimes.
It can be, definitely.
Like those solar flares and coronal mass ejections can mess up satellites, communication systems, even our power grids here on Earth.
Oh, for sure.
So, understanding how the sun behaves isn't just about scientific curiosity anymore. It's about protecting our technology.
Yeah, you got it.
But how do supercomputers help us do that?
By creating crazy detailed 3D models of the sun, scientists can study what's happening inside it.
Oh.
They can simulate things like how the solar plasma moves, how magnetic fields are generated, and even the origin of those solar flares.
Wow, so it's like having a window into the heart of the sun.
It really is.
That's so cool. What are they hoping to learn from all this?
Well, the goal is to be able to better predict those solar storms and other space weather events.
Oh, I see.
If they can understand what causes them, then they can develop early warning systems to protect our technology.
It's like a weather forecast, but for space weather.
Exactly.
Instead of telling us to bring an umbrella, it tells us when to, batten down the hatches and protect our satellites.
Yeah, something like that.
Awesome. And these simulations can also help us understand the sun's behavior in general, right? Which can then teach us about other stars in the universe.
Exactly.
Okay, so from launch pads to airplanes, neutron stars to the sun, it's clear that supercomputing is doing some serious heavy lifting for NASA across all these different areas.
Sure.
But wait, there's more.
There is.
This article also mentions something called scientific visualization.
Yeah, that's cool stuff.
It sounds pretty intriguing. Tell me more.
Well, scientific visualization basically takes raw data and turns it into something that's visually stunning and easy to understand.
Okay.
It's about making complex science relatable to everyone.
Oh, I see.
So tell us more. How is NASA using supercomputers for scientific visualization?
Well, NASA has something called the Scientific Visualization Studio, or SVS.
Okay.
And they use supercomputers to transform complex data sets into images, animations, you name it. They even create virtual reality experiences.
So instead of just looking at numbers all day,
Yeah.
scientists can actually see their data come to life.
Exactly.
That's amazing. It's like you can peek inside a black hole or watch a star being born. You can even see those tiny molecules dancing around during a chemical reaction.
Oh, wow. Okay, that's seriously cool.
Yeah.
But it's not just about making pretty pictures, right? What's the point of all this?
Well, it's a powerful tool for scientific discovery and communication.
How so?
For scientists, visualization can help them find patterns and make connections in their data, things they might miss just by looking at numbers.
Okay.
And for the rest of us, it helps us connect with science in a way that we can actually understand.
Yeah, instead of just reading about a black hole, you can actually see what it might look like.
Exactly.
It's a way to make people curious about the universe.
Exactly.
I love that. And the best part is, the SVS makes all of its visualizations available to the public for free.
They do.
So anyone can explore these wonders of science and space, all thanks to supercomputing.
It's amazing.
I know. Okay, we've covered a lot of ground today, from what supercomputers are and how they work, to their amazing applications in space exploration, climate modeling, and so much more.
Wing out.
It's clear that supercomputing is this incredible force driving innovation and discovery in so many fields.
It really is.
But before we get too excited, I think it's time to take a step back and look at some of the challenges and limitations of supercomputing. Because it's not all sunshine and roses, right?
It's not. There are definitely some challenges, and we'll talk about those in part 2 of our deep dive.
All right, sounds good.
Supercomputing, it's this amazing tool, can unlock so many doors, but there's still some locks out there that it just can't pick.
Okay, I like that analogy. So what are some of the challenges then that scientists are dealing with when it comes to supercomputing?
Well, one of the biggest hurdles is data.
Data.
Yeah, supercomputers generate a truly mind-boggling amount of information.
Okay.
We're talking terabytes, petabytes, even exabytes of data.
Okay, I'm not really sure what all that means. Can you put that into perspective for me?
Imagine trying to store all the books in the Library of Congress,
Okay.
but 1,000,000 times over.
Wow. Okay, that's a lot of digital books. So how do scientists even manage and make sense of all that information?
It's a huge challenge. Just storing it all, managing it, and then analyzing it requires specialized infrastructure. You need experts.
Okay.
It's not just about having powerful computers. It's about having the right systems and software to deal with that massive amount of data.
So it's like having a giant library, but you need a super efficient librarian to help you find the books you need.
Yeah, exactly. And then there's the energy consumption to think about.
Oh, right. I bet those supercomputers use a lot of electricity.
They do. They're power-hungry beasts. They need a ton of electricity to run.
Which makes sense. I mean, all those processors working at once must generate a ton of heat.
They do. And as we're trying to move towards more sustainable technologies, the energy footprint of supercomputing is a big concern.
Yeah, for sure.
Researchers are always trying to find ways to make them more efficient, but it's a tough challenge.
So it's about balancing the power of computing with using energy responsibly.
Exactly.
What about limitations in terms of what supercomputers can actually simulate? Are there things that are still beyond what they can do?
Oh, absolutely. While they can model really complex systems,
Yeah.
there are limits to our understanding of the universe.
Okay.
For example, we're still trying to understand dark matter and dark energy.
Right. The stuff that makes up most of the universe, but that we can't see. So we can't just program the laws of physics as we know them into a computer and expect to get all the answers.
Not really. We still need human ingenuity and creativity to guide the research and understand the results.
So even with these powerful computers, we still need good old-fashioned human brains.
We do, absolutely. Supercomputers are tools, but they're just tools.
Okay.
We need humans to ask the right questions, design the experiments, and make sense of all that data.
Like having a super-powered telescope, but needing an astronomer to tell you what you're looking at.
Exactly. And speaking of human expertise, we need more skilled people who can build, operate, and maintain these complex systems.
So it's not just about the technology itself, it's about having the people who know how to use it.
That's right. We need more computer scientists, engineers, data analysts who can really push the boundaries of supercomputing and solve real-world problems.
That makes sense, especially as these technologies become more common in different industries. We need people who are ready to use them.
Right.
What about collaboration? Is that important in the world of supercomputing?
It's crucial.
How so?
Well, the challenges we face are global, like climate change, space exploration. These are things that no single country can solve on its own.
Yeah.
We need to collaborate, share data, tools, and expertise.
There's breaking down walls and working together.
Exactly. And we're seeing more and more of this open science where researchers share their data, their software, everything.
That's awesome. So everyone can benefit from each other's work, and we don't have to start from scratch all the time.
Exactly.
That's great. Okay, so we've talked about data, energy, the limits of simulations, the need for skilled workers, the importance of working together. Anything else we should consider?
One more thing, it's accessibility. Supercomputers are expensive.
Yeah.
Not every university or company can afford one.
Right.
So we need to make sure that more researchers have access to this technology, not just a select few.
So democratizing access so that everyone can benefit.
Exactly. And there are ways to do that, like cloud computing, where you can access supercomputing power remotely.
Oh, that's cool.
But it's still a challenge to make sure everyone has access.
It's like making sure everyone has the tools they need to succeed.
Exactly. And as we keep pushing the boundaries of supercomputing, it's important to keep these challenges in mind.
It's a good reminder that even the most powerful technologies have their limits. But it sounds like people are working hard to make supercomputing more accessible, more efficient, more sustainable.
Definitely.
You know, thinking back to what we talked about earlier, scientific visualization.
Yeah.
It seems like that could help with some of these challenges, right?
It could. Visualization can really help us understand huge amounts of data.
It's like making a map of a really complicated landscape so that you can find your way around.
Exactly. And it can also help explain complex science to people who aren't scientists.
Right, because sometimes a picture is worth 1,000 words, especially when you're dealing with really complicated ideas.
That's right. Visualization can make science more engaging, even inspiring.
So it's not just about crunching numbers, it's about making those numbers mean something.
That's right. And with all the new virtual reality and augmented reality stuff coming out, the possibilities for scientific visualization are really exciting.
It's true. Imagine being able to walk around inside a black hole or explore Mars from your living room.
That would be amazing.
Okay, let's shift gears a little bit now and talk about something a bit closer to home, climate change.
Okay.
I know supercomputing is playing a big role in helping us understand this crisis, right?
It is. Climate models are incredibly complex. There are so many different things to consider.
Right, the atmosphere, the oceans, ice, forests, humans.
Everything. It's like creating a digital twin of the entire planet.
Wow, that's a massive undertaking.
It is, and that's why we need supercomputers.
So they're essential for running these models and making predictions about the future.
Exactly, and not just predictions.
Oh.
They can also test different scenarios,
Okay.
like what happens if we reduce emissions, or what would happen if we use different technologies.
So it's like having a virtual laboratory for the whole planet.
Yeah, and that's crucial for making good decisions about climate change.
It gives policymakers the power to see the impact of their decisions before they make them.
Exactly, and as these models get better and better, they'll be even more helpful.
So supercomputing isn't just about science, it's about giving us the tools we need to protect our planet.
It is, and it's also being used in medicine, energy, engineering.
That's amazing. The same technology that lets us explore space is helping us here on Earth.
It shows how connected science and technology really are.
Yeah, and it reminds us that pursuing knowledge and innovation can benefit everyone.
I agree.
Let's take a quick break here, and when we come back, we'll talk more about the broader impact of supercomputing on society. All right, so let's talk about the bigger picture now. How does supercomputing impact society as a whole?
It's not just about those scientific discoveries, right?
Yeah.
Supercomputing is actually driving innovation in tons of industries.
Okay, like what? Give me some examples. Where are we seeing its influence outside of the lab?
Well, think about things we use every day, like safer cars with those fancy collision avoidance systems, or more fuel-efficient airplanes.
Yeah.
Even personalized medicine that's tailored to your genes. All that stuff relies on supercomputing behind the scenes for simulations and data analysis.
So it's like a secret ingredient in all this technological progress.
Uh-huh. Yeah, kind of. And it's not just about making things better, it's creating whole new industries.
Oh, really?
Think about artificial intelligence, biotechnology, renewable energy.
Yeah. Okay.
Supercomputing is pushing the limits of what's possible in all those fields.
So it's making better stuff and making new stuff.
Exactly.
And that has to have a big impact on the economy too, right?
Absolutely. The supercomputing industry itself is booming,
Yeah.
creating new jobs and driving economic growth.
Okay.
And all those innovations that supercomputing makes possible are leading to new products and services,
Yeah.
which boosts the economy even more.
It's like this chain reaction of progress with supercomputing leading the way.
That's a great way to put it. And we can't forget about education and the future workforce.
Right, because as supercomputing becomes more important in different fields, we need to make sure people have the skills to keep up, right?
Absolutely. It's more than just teaching people how to code.
Okay.
It's about understanding computational thinking, analyzing data, solving problems with these powerful tools.
I say, so we need to encourage those skills in young people, those problem-solving skills.
Exactly. We need future innovators and problem solvers.
So they're not just using technology, they're creating it.
Exactly.
Okay, we've covered a lot of ground today.
We have.
From the nuts and bolts of how supercomputers work to their impact on science, technology, and even society as a whole. It's clear that supercomputing is this incredible force that's shaping our world.
It really is. And as it keeps getting more powerful, who knows what amazing things we'll see in the future.
It's a really exciting time to be alive and watching all this happen. Well, thank you so much for joining us today and sharing all your insights. This has been a fascinating conversation.
It's been my pleasure.
And for everyone listening, thanks for coming along with us on this deep dive into the world of supercomputing.
Yeah, thanks for listening.
We hope you learned something new and maybe even feel inspired to learn more.
Definitely.
Remember, the future is being built with data, and with supercomputing, the possibilities are endless. So keep those minds curious, and we'll see you next time.